I work on a range of things in mathematical biology, from looking at how infectious diseases spread, but also looking at how skin repairs itself after it's damaged. So what I do is I use mathematics to create a model for how skin cells talk to each other and how their processes are regulated by chemicals in the body in order to coordinate a healing response. My name is Jennifer Fleck and I'm an Associate Professor in the School of Mathematics and Statistics at the University of Melbourne. Mathematics is the abstract science of numbers, quantities and space. So this can be broken up into two broad categories. There's pure mathematics, which is studying numbers, quantities and space in its own right, and applied mathematics, which is applying these ideas and concepts to applications, say, in biology or physics. Statistics is the science of collecting and analysing large amounts of data. The purpose of statistics is to understand patterns that are behind data. Students are able to take mathematics and statistics regardless of what they've studied at high school, and the way that this works is the entry point is different depending on the background of the subjects that you've studied at high school. So in my opinion, studying mathematics and statistics equips a student to be able to apply their quantitative skills to a broad range of problems. Studying mathematics and statistics opens up a world of possibilities to a student in that they can apply their mathematics and statistics to a broad range of applications. It can range from anything from modelling infectious diseases down to looking at climate change, looking at financial patterns and trying to predict financial markets. It's very broad. Studying mathematics and statistics will enable a student to get a generalisable skill set which includes computer programming, scientific writing and communication skills. Also in the undergraduate degree there's an opportunity to work together collaboratively in group assignments. I chose to study maths and stats because I love the idea of problem solving, taking a problem and abstracting it, solving the problem in that abstract space and then putting it back in terms of the original problem and interpreting it in terms of what the original problem was. What I enjoy most about teaching is interacting with students and finding out the ways that individual students can best understand new concepts. In the first year of a mathematics and statistics degree at the University of Melbourne, students will be exposed to our foundation subjects where they build up their skill set in mathematics and statistics, which then prepares them for further study in a specialist area. Some of the foundation subjects in mathematics and statistics include calculus, linear algebra, and introduction to probability. So there are practical classes in mathematics and statistics that include computer laboratories, and so in these you would learn to use cutting-edge software like MATLAB and R in order to be able to do data visualization and to do numerical analysis. So once a student has a solid foundation in mathematics and statistics, they'll be able to build mathematical and statistical models that are capable of explaining problems outside of mathematics and statistics, and this might come from fields such as biology, physics, chemistry, finance. I think one of the biggest misconceptions about studying mathematics and statistics is that there's no jobs at the end of that study for you. And that's simply just not the case. There are lots of opportunities. So in this way, mathematics and statistics is really a building block for all scientific research. Mathematics and statistics is a really important part of the toolset that enables scientists to tackle real-world problems. I think an inspiring example is the way that mathematics and statistics has played a really important role in the COVID-19 epidemic, and we've seen it on the news almost every night. We've seen effective reproduction numbers and we've seen model predictions in a way that we hadn't seen previously. So another really interesting application of mathematics and statistics is looking at landslides and how we can best evacuate people safely from a landslide. So for example, when you're in your first year, you learn ideas about calculus, and then in your second year, you'll learn stuff about differential equations. And then once you have a foundation in differential equations, you'll be able to do stuff like model how the shape of a beam changes to model how an infectious disease spreads through a population. My advice to a first year mathematics and statistics student would be to get that foundational knowledge, and then in second and third year to find the specialisation that you're really passionate about in order to really love the subjects that you're studying.